Hello guys, today we will see the Leetcode problem number 712, minimum ASCII delete sum for two strings. Okay, so what the problem says is the two strings S1 and S2 are given to us and return the lowest ASCII sum of deleted characters to make the two strings equal. So to make two strings as equal, so we have to delete some of the characters. So and to minimize that sum, that how many characters are we have to delete, their lowest ASCII sum we have to return. Now just think about it. If we want to delete the sum of the characters, so if you want to delete some of the characters from the SEA and EAT, so how many minimum characters we will delete? We can delete S and we can delete T, and we will have the E and A as a longest common subsequence. So think in a manner that a longest common subsequence we have to get by deleting some of the characters. Okay, now here the concept of the longest common subsequence will be taken, and we have to find out the cost to make the longest common subsequence, and after that we have the cost of longest common subsequence. So we can subtract that cost from the total ASCII values of which are the characters which are present in S1 as well as S2. Okay, so what the approach over is, we have the total value containing the ASCII values, means we can say as a total value which is presenting the ASCII values of S1 ASCII values of S1 and ASCII values of S2, sorry, with the characters which are present in ASCII values of S1 and ASCII values of S2. Okay, S2. Okay, then we will take it as a equation number 1. After that the equation number 2 will contain the ASCII value to make the longest common subsequence. Okay, this will be the equation 2. So now we will having our answer means the number of characters which we are deleting. So the answer 1 minus of equation 1 minus of equation 2. So after that we will get the number of characters which we are deleting. Okay, because these are the number of characters which we are taking, these are the number of characters which are total. So the total minus of taking, we will get, by subtracting them we will get the number of characters which we are deleting. Okay, now the number of characters which we are deleting will be just take as an example. Okay, so approach our is, when we have these adjacent elements as a similar, so we will take them as a longest common subsequence. So we will apply the longest common subsequence on this total 2D array. Okay, and after we will get the cost for the longest common subsequence. Okay, now S and E is there, so S and E are not same, so that's why we will get the maximum from this 2. Okay, means that we can delete this, or we can delete this A. Okay, now after this we have S and A. Now these are also different, so we will take maximum from this 2. Okay, now maximum from this 2 we have taken. Okay, now we have S and T, so these 2 are also different, so that's why we will take the maximum from this and this. Okay, now we have the E into it. E and E both are same, so that's why we will delete them, means we will take as the longest common subsequence. And also we will add the cost for this. The cost for this we can see here as a 69 as a cost. So we will add this 69 to it, 69 plus this cost. Okay, so this cost will be added here. 69 plus 0 will be the 69 only. Okay, after this we have E and A. So E and A both are not similar, so we will have to get the maximum from this and this, which is 69. Okay, now again we have T and E, both are not same, so we will take the maximum from this or this cell, 69. Okay, maximum. Then we have E and A. So E and A both are not similar, so that's why we will get the maximum from upper cell and this cell and this cell, so which is 69. Now we have the A and A as a similar one. Okay, A and A are both are similar. Okay, so A and A both are similar. Now we will take the ASCII value of A is a 65. Okay, which is, you can see here, the 65 ASCII value. Okay, so now we will add this 65 with 69. Okay, 65 with this 69, and we will get 134. Okay, as the value, total value, and 134 will be stored here. Okay, after that we have A and T, which again are not similar. Okay, so we will get the maximum from this area or this cell and this cell. Okay, so now our answer will be the 134 for the longest common subsequence. And now we will calculate the total ASCII value from the S1 and S2, and after that we will subtract this minus with this values with the ASCII value required for the which is required for making the longest common subsequence. Okay, let's see the code. Okay, in this code we have the, okay, first we will erase all. Okay, now we have initially stored the sizes of the string 1 and string 2, then max underscore 0 means the maximum score of the longest common subsequence. So either we can get this counter, or we can already return the dp of n1 and 2. So this will also containing the same score. Okay, which is the total score for the longest common subsequence. Okay, we can do this also. After that we have made the 2D DP array, and after that we are getting the 2 double for loop. After this, now this is the main condition, where if we have both the adjacent characters as a similar, so we will get them get the initial value plus the ASCII value of that particular character. Okay, and the initial value by deleting both of them. Okay, and if they are not same, so we will delete any of them, either from I or either from J. So we will take the max from this too. Okay, after this here we are storing the maximum value. In place of this we have discussed that we can also, in place of this, we can also return the direct value of n1 and 2, because this will be also storing the longest common subsequence value. Okay, final longest common subsequence cost. Okay, now we will first calculate the total cost. Total cost means total ASCII value of the characters which are present in the S1 as well as S2. Okay, then After this we will be calculating our answer as total minus of max underscore minus into 2. Why this max? What the max is indicating? The max is indicating the total value for longest common subsequence, LCS, longest common subsequence. Okay, this after this we are multiplying it with 2 because the longest common subsequence will be similar for both S1 as well as S2, so that's why we are multiplying it with the 2. Okay, and because that when in longest common subsequence the characters which are deleted from S1 also deleted from S2, that's why we are minus it with the multiplication of 2. Okay, and this is the overall solution. If you are not getting any of the concept, so please comment down below and I will be answering your question. Thank you.